Algebra 2.1, this is Mr. Carlson. We are going to learn complex numbers. Very similar to imaginary numbers, but just a little bit different. Okay, so we're going to be going through more advanced techniques of how to simplify these things with different operations. But for that, let's go through bell work so that we actually understand not just imaginary numbers, but kind of how complex numbers go through the homework quiz, and then after that, we're going to go through the actual lesson. So let's go to town. Yeah, I'm excited. You're excited? If you're not excited, get excited. All right, so today we have these questions on our bell work. Dividing, adding, and then multiplying. So get them down, pause the video if you need to. Okay, so first thing I'm going to do is I'm just going to rewrite it. And I'm going to actually pull out an I. So remember, pull out an I first, and then divide by 40. I'm going to look at this 75, and this is 25 times 3. And then this is 5 and 5, which combine. So negative 20 plus 5i, and then what's left over is the radical 3 right here. And this is all over 40. Okay? So far, so good. Now, everything is divisible by 5, so that means I'm going to divide all the numbers, not the 3, but all the numbers, 5, 40, and negative 20. 5, 40, negative 20, I'm going to divide those by 5. Negative 20 divided by 5 is negative 4. 5 divided by 5 is just 1, so I'm just left with this. And then 40 divided by 5 is 8. This simplifies down to negative 4 all over 8, and then plus I, radical 3, all over 8. Which simplifies down even more to negative 1/2 plus I, radical 3, all over 8. Okay, so that is my final simplified answer. Sort of long, but probably took me like, 30 minutes? No, wow. 30 seconds to kind of get through it and sort of know what to do. So practice. Go on Math Excel, do your homework, practice. This one, fairly simple. They're both perfect squares, 64 and 9, and then they both have the negative, which means I'm going to pull out the I, of course. So now what's so far is 2i, and this is radical 64, plus this will be 5i radical 9, and so this is going to be 2i times 8, because radical 64 is 8, radical 9 is 3, and so this becomes 16i plus 15i, which reduces down to 31i, which is technically 0 plus 31i. I do not know if Math Excel wants you to put it in this form, but I'm almost positive they want you to put it in that form. Okay? Cool. So that's how you do that one. Sweet. So this one right here, what do I do? Well, first of all, like I said, pull out an I. You need to kind of simplify these radicals here. So 10 and then I and then radical 13. Notice how 13 is not a perfect square, which is unfortunate, but that's okay. And then this is actually a perfect square, which just becomes I, because radical 1 is just 1, and then radical 1 underneath the radical. Radical 1 is just I, but 1 itself is the square root of 1 itself is just 1. So I have that, and now I'm going to multiply together. 10 times negative 6 is negative 60. I times I is I squared, and then times radical 13. Okay, times radical 13 here. And so I squared is a negative, so negative 60 times negative 1, and then times radical 13, which reduces down to, of course, 60 times radical 13, which equals that. I'm just going to put the plus I on the end. Technically, it's plus and then 0i. So that's technically my final answer. Basically, sort of, kind of, that is my final answer. Okay? I hope that was nice. A lot easier than the bell work for the Unit 1, right? Because that's all I have for you. I don't have anything else. Your tests, homework quiz, I think, let's find out together, actually. I don't remember how many minutes I put on there. So if you don't have this, please make sure you have it. I'm going to erase. 25 minutes, that's solid. So 25 minutes, 5 questions for imaginary numbers. Get to it. You can pause the video right now if you want to. Start on that, come back, and start on the lesson for today. Complex numbers, very, very similar to what what we learned yesterday. Very similar. We're just now going to be doing a little bit more, maybe different operations. So, how do I perform operations on and graph complex numbers? How do I perform operations on and graph complex numbers? Okay, I love this. This was totally me in like elementary school. Okay, my girlfriend and I are like complex numbers. I'm the real part, and she's the imaginary part. Um, Very interesting indeed. Fun fact about me. Okay, I usually always had a girlfriend from 7th grade all the way until about 10th grade. 10th and 11th grade were the only years that I didn't have a girlfriend, from 7th grade and on. So by didn't have a girlfriend, that means like I always like had one, like always had one. Kind of weird to think about it, but fun fact about me, get to know me a little bit more. If you think that's gross, I kind of do too. Whatever. Let's get started. Okay, so complex numbers. This is what it is. Remember, I told you we were just going to review this slide from yesterday, and I said yesterday that we're going to review the slide tomorrow. Today's tomorrow. Today's tomorrow. So that means this should already be something that you technically maybe already have. All this means is that this is our standard form. We already sort of did that yesterday, so I'm just reviewing it today. Okay, so your BI, that's what we call my complex form. It looks like that. It's my fancy complex symbol with a C and then like a little line in the middle. That's what we call my complex or purely imaginary part. Okay, this A is what we call my real part, normal numbers that I usually see. Fun fact, pi, that is actually a real number. Okay, radical 2, that's actually a real number. All right. 1/2. This is what we call a real number. What is an imaginary number is 2i, 7i, pi I, radical 2i. Okay, those are all imaginary numbers. So whenever you see an I in it, it's imaginary. When there doesn't have any sort of I at all, it is real. You can even have 2x, by the way, and this is technically real. Okay, there's no way that that's going to be an imaginary number. You can have though 2ix, and that would be not that would not be real number. That would be a complex number right there, a C. Okay, so that's kind of for free. You don't need to know that, all right? But I wanted to tell you that's sort of how you distinguish between the two. Okay, so we're going to treat I just like a variable. We're going to go through addition, subtraction, multiplication, and yes, of course, we are going to be doing division and doing a fancy little thing with that. And then what I'm going to do is I'm going to show you how to plot them on an XY plane and then kind of bring inside what we call the absolute value of a complex number system. So lots of stuff that we're going to go through today. Let's start out with the very basic. Okay, let's get started. So notice how this has a plus sign in the middle and it has parentheses, which means it's kind of confusing you because you would think you just need to multiply, but the plus sign is the thing that's really what we're after. So this really just means add them up. So we can drop the parentheses essentially and just combine like terms. So 2 plus 3 is 5, and then -9 plus 5 is -4i. And then we are done. That's what this equals. And if you're thinking like, really? Seriously? Yes, seriously. Okay? So that's what it is. Adding and subtracting complex numbers. Now this does have a negative, and that means we do need to distribute that negative in, which means I'm going to change all the signs here, just like this. When I do this, it's the exact same thing as distributing. If I distributed that negative through, it just changes all the signs, which is exactly what I did. And now what I can do is take 7 plus 2 and then plus 8. So I'm going to do this all in one sitting. Ready? 7 plus 2 is 9 plus 8 equals 17. Okay, and then I have -7i, and then plus I is going to be -6i. So this is my final answer. Okay? It's that simple. Okay, we're going to town on these. Look at us. Okay, now let's do this one. I do have a negative here, so I need to make sure I distribute that negative, change my signs. So now I have 2 and then negative 9. So that together gives me negative 7. And then 8 and then 8 give me plus 16i when I add them. Negative 7 plus 16i. And that is my final answer. Not too shabby, right? Not too difficult. And that's hopefully what it should be. So that's adding and subtracting. Let's get to multiplying, and then I'm going to show you a little trick with division and then plotting, and then we're done. So multiplication. Well, first off, you do need to treat the I just like a variable. And I told you that on the last video, you need to treat the I like a variable, just like you treat a radical like a variable oftentimes. And then you replace it with a negative 1 when you get to I squared, because that is one of our fundamental foundations that we learned in the last video. So what do I do here? I do exactly what I normally do, just distribute, right? 5 times 8 is 40i, so this equals 40i. 5i times negative 3i is negative 15i squared. I squared is just negative 1, so this becomes plus 15, okay? Now, if you want to leave it in this, you can, but I'd rather do it in the actual form. So this is 15 plus 40i. I'd rather actually put it in my standard form here, okay? So that is my final answer. Remember, this right here, this I squared, that equals a negative 1, okay? So that's why negative 15 times negative 1 gives me a positive 15. That's why I have the positive 15 there. This one right here, we're going to just multiply FOIL just like we normally would. 9 times 9 is 81. 9 times negative 6i is negative 54i. And then I have the same thing here, positive 54i. And then the same, sort of the same thing, not really. And then this is negative 36i squared. These actually go poofy, so think our lucky stars. 81 minus 36 times negative 1, because that's what I squared is. And so this becomes a positive 36, so 81 plus 36 is 117. Okay, now this is interesting, and now I'm going to actually pinpoint this. This problem right here, notice how we kind of did this problem. This problem is what we're going to be calling in a little bit, what we call the complex conjugate. It's a very complicated word, okay, but conjugate. This is what this formulation is, okay, the complex conjugate. Why is that? Because you see, they're literally the exact same numbers. One difference, positive, negative. Now notice what happened here. This is very, very important. Notice, watch. The middle terms go poofy, okay? They go poofy. And this is what we want, especially when we get to division. So I'm going to hold off on that, but keep that in mind that we want to do something like this, and we can manipulate our equation, our expression, in such a way as to get the answer that we want in certain areas of mathematics, namely complex numbers and division. But I wanted to show you that with multiplication, that really this is actually a formula embedded within here, an identity, and that is that the middle numbers go poofy. And I really just needed to do the first and then the last numbers, and I get that number, okay? Because this is the first, and then this is actually my last numbers. Notice my O and my I in FOIL, my outside and my inner terms in the FOIL method, FOIL, first, outer, inner, last. My first is right here, my last is right here, but my O and then my I, my inner terms, they actually go poofy on each other. That's what we call a complex conjugate, okay? Keep that in mind. Let's continue on to some others, okay? If you feel like you can actually do these yourself, go ahead and pause the video. Pause the video and then come back and then see if, as I explain it, it's helpful to you, or you maybe found a mistake, or if you're right. So this is the exact same thing. I'm going to FOIL. So negative 4 times 7 is negative 28. Negative 4 times I is negative 4i. Negative positive 2i plus times plus 7. That sounded weird. Negative 2i times 7 is negative nothing. Wow, holy junk. my life. Positive 2i times positive 7 gives me a positive 14i. Done. Positive 2i times a positive I is positive 2i squared. Okay, so let's continue simplifying this. This becomes plus 10i, and this actually becomes negative 2, and so this becomes negative 30, and then plus 10i. That's my final answer. Okay, now, what do I have here? This is just duplicated, so what this means is literally just 2, and then plus 8i, and then 2 plus 8i. That's what that means. So let's simplify this. 2 times 2 is 4, and then I have 2 times 8i, that's going to be 16i. And then I have 8 times 2, well, that's an I, and then plus another 16i. And then 8 times 8 is 64, and then times I squared. Okay, so this becomes 4 plus 32i, and then this is minus 64, and so this equals negative 60 plus 32i. That's my final answer. Sweet. Okay, now that's multiplication. Let's get on to what we call division, but before we do that, I need to talk a little bit more about the complex conjugate. So, complex conjugate is this. Don't freak out, because the only thing you really need to write down is this right here. This what I boxed right there in orange. So the a plus bi and then the a minus bi. Now notice again, once again, a and B, they're the exact same numbers. Really, all I have to do is the first and the last term, because the O and the I cancel out. So I'm going to show you that right here. Now this second line is literally the exact same thing. It just takes the minus before the positive. This one's the positive before the minus. It doesn't matter because it's commutative properties. So when I actually multiply this out, a times a is a squared. A times negative bi is minus a and then bi. And then bi times a is positive a and then bi. Bi times negative bi is minus b squared and then I squared. Okay? Because b times b is b squared, I times I is I squared. Now, notice what happens here. First of all, this right here is my first. This is my outer. This is my inner. And this is my last term. My O and my I go poofy. So when you have a problem like this, when it's sort of in this sort of format, this process, what you can do now is just skip the O and the I, because you already know they're going to cancel or poofy out, right? So now really all you need to do is make sure you do the A squared, the first term, and then the last term, which of course this equals a squared, negative b squared, and then times I squared. I squared is negative 1, so negative b squared times negative 1 is a positive b squared, which is the exact same thing that you get here and here. Okay, so what am I going to do? When I start showing these problems, I'm more than likely going to skip the outer and inner term. That's the purpose. I'm going to skip the outer and inner term here because I don't need to show it, because I already know, trust the math, I already know that they're going to go poofy, okay? Because that's what the math tells me. So let's erase this. That's the complex conjugate. Let's actually put it into action. Multiply by the complex conjugate and then simplify. So I have a problem like this. This is division. I want to express it in standard form, but what will this look like? Well, I'll show you what it looks like. First off, I need to multiply, just like when I rationalize, very similarly, when I rationalize, I multiply both the bottom and the top by the complex conjugate. Why do I do that? Because what I do to the denominator, I have to do to the numerator. So this is going to be 6 plus I. Notice what I did there, 6 plus I. And then this is also 6 plus I. So now what this equals is I can actually multiply this through just like normal on the top of my fraction. 3 times 6 is 18. 3 times I is just plus 3I. On the bottom here, watch, I already know, since it's minus and positive, and they're the exact same 6 and I in both sets of parentheses, that the outer and the inner term will go poofy. Do I need to waste my time on that then? You can if you want, but you're just wasting your time. It's basically like you might as well put 2 plus 2 equals 4 on the calculator. Trust the math. All you need to do is this, okay? In purple, you need to do the first terms. 6 times 6, 36. And then the last terms. Negative I times I is negative I squared. That's it. That's all you need to do. If I decided to do this, and if you don't believe me, 6 times 6 is 36, and then right here is plus 6i. Then right here in the inner term, minus 6i minus I squared. You probably thought I was having a stroke there, right? I will have a stroke if you continue doing this, okay? Obviously, trust the math, it will go poofy. I only needed to do the first and the last terms. The outer and the inner terms go poofy, okay? Okay, now let's simplify this. I know at the bottom that's just going to turn into a negative 1. A negative times a negative 1 is a positive. So this is 18 plus 3i. And since this is going to be 36 plus 1, this is going to be 18 plus 3i all over 37. But hey, it's not in standard form yet. So let's put it in standard form. This is 18 all over 37 and then plus 3i all over 37. That is my standard form. That is my final answer. Okay? So not too difficult, I hope. Maybe. But if it is, by all means, replay the video or come in for tutoring and we'll go to town. All right, now let's go to this one. See if you can do this one by yourself. Try to pause the video and see if you can just get as far as you can. Try it. Practice the math. You got this. Okay? Okay, let's start. So I'm going to multiply by the complex conjugate. So this is 3 plus, in this case, 6i. And I'm going to do the exact same thing here. 3 plus 6i. The purpose, again, is to get the i's out of the denominator. That's really the purpose. The purpose is to get the i's out of the denominator here. That's what I did here. Okay? If they were in the numerator, I wouldn't care because I could just do this, which I did. So this is why we do the complex conjugate, guys, because I want to actually simplify it in the standard form. But in order to do that, I need to multiply by the complex conjugate to put it in standard form, to get it out of the denominator. So multiply straight through. So this equals 5i times 3 is just 15i. 5i plus 6i is going to be 30. I'm going to skip a step here. That's going to be 30i squared, positive 30i squared. So this becomes negative 30, okay? Because I squared is negative 1 times a positive 30 equals a negative 30, okay? Just wanted to skip a step there. I hope that's okay. And then right here, remember, you only need to do the first and then the last. So 3 times 3 is 9, and then the last is just going to be negative 36i squared. Okay, this equals 15i minus 30, and then all over I squared is negative 1 times negative 36 is a positive. I'm going to skip another step here, so follow with me. So negative 1 times the negative 36, positive 36, plus 9 gives me what? So if this is a positive 36 plus 9, that's going to be 45, right? So this is going to be a positive 36 and then 9, that's 45. It's positive because I squared is negative 1. So this is 45. This equals, I can divide everything by 5 here. I can actually divide everything by 15 here. So I'm going to do that. Divide everything by 15. So that's going to be minus and then 2 and then all over. And then this is going to be 3, right? So this equals I all over 3 and then minus 2 all over 3. Not bad. Not bad at all. Sweet. You can flip this. I'm just trying to think about how maybe we want to simplify this. I'll probably flip this because this is the same thing. So negative 2 all over 3 and then plus 1 all over 3i. That means the exact same thing too. So let's just call that my final answer. How about that? Let's call that my final answer and be solid. Be jiggy with it. Okay, make sure you pause the video and get that down and we'll move on. All right. All right, so now how do I plot? This is actually really easy. We have two more things that we need to do. Plotting, and then we're gonna go through what we call the absolute value. So 3 more slides, we done. 3 more slides, we done. Okay, how do I plot? Well, I'm given these options. Now, why is it called Z? Well, that's just something that I can call it. Don't worry too much about the Z. It's just Z something, so it can be Y equals whatever. It doesn't matter. But notice one important difference. Imaginary and real. So now this is usually my y-axis and this is usually my x-axis. My x-axis will stay the same. My imaginary number though is now, my y-axis is now going to be my imaginary axis. How do I plot this? Well, I'm going to do this one in pink. So let's go for it. This is my real part. So I go over 3. So 1, 2, 3. And this is my imaginary part. So I go up 4. So it's essentially like saying this, 3, 4. Okay, so I go up 4 and then boom, this is my point. Yes, it is that easy. So this right here is what we call 3 plus 4i in pink. Yep, you're done. And you will have a question on the homework quiz that's literally like that. Straight up. You're welcome. Okay, very simple. Now let's do this in B. This is the same thing as negative 1, negative 2. So I'm just going to plot it. So negative 1 and then negative 2 right here. So this is negative 1 minus 2i. See if you can do the other ones. Let's do this one in red. Now, what's the imaginary part here? This is going to be plus 0i. So this is the same thing as negative 3, 0. Okay, remember, x equals my real part, and then my y equals my complex part. Okay, so just notice that. Maybe write that down in the margins. That will help you. So really my point here would be real, and then comma, complex. That's kind of what my point is here. My fancy R and my fancy C there, that's what it really is. So negative 3 all the way over and then 0, and that means I go up literally none. I don't go up at all. So this is just negative 3 on my x, y, or real and imaginary plane. And let's do this one in like a greenish color. So this one right here, what's my real part? Still technically 0. So this is actually, my real part is 0 and then negative 4. Okay, so 0 and then negative 4 is right here. Okay, so this is negative 4i. Perfect. So that's how you plot. I mean, it's really that simple, guys. Seriously, it's that simple. It doesn't need to get too much more complicated than that. I hope that's okay. Yes. All right. So now let's erase this. Let's get into what we call the absolute value of complex numbers. Now, it looks more scary than it is, but it's not. So what do you really need? You really need to not do that. Give me a second. Oh my gosh. I'm going to just kill something. Okay. So what you really need is to know this. So please put that in your notes. That's probably the most important. Okay. All right, and some of you have been asking, like, what's that period? Does that mean anything? That's just literally a period. In math, when you just write it like a math symbol. So it's basically him finishing a sentence. This book right here, where I got this, the absolute value of a complex number a plus bi is absolute value of z equals the absolute value of a plus bi equals the square root of a squared plus b squared, period. Okay, so you don't need to write the period. FYI. Okay, just the formula part. Now, what this does, when it asks you find the absolute value of the complex numbers, what does it ask? Well, it asks you to calculate the distance. Calculate the distance of the complex number from the origin. So this is the origin, of course, on my new xy plane, so my imaginary and my real axis. This is the distance. Can I not move this? Can I not move my freaking face? Aw, jeez. Whatever. Okay, so yeah, this is the distance, all right? So this is the real axis, and then this is the imaginary axis. Now, pay very close attention. You ready? What's happening here is it's taking this point, okay, A plus BI, it's taking that point, and then the origin, 0, 0, okay, 0, 0, and then it's basically performing this action. Now, this is technically the distance formula. I'm not going to get too much into this because I explain it way more when you take my trig class. But this is technically the distance formula, guys. Okay? It's also technically called the Pythagorean theorem. Okay? It is the Pythagorean theorem, obviously, because you see a freaking triangle here. Okay, really what you're doing is a squared plus b squared, and then you have z squared, but you don't square that, you square root, and then that's why you have the square root here. Okay, it's a fascinating little discovery. I don't want to get too much into it because I don't want to waste your guys' time, but if you're more interested in that, let me know. But essentially, this is what you're trying to do. You're trying to find this in red, the distance. And how do you do that? Well, you take your a value, square it, you take your b value, not your imaginary value, your b value, your coefficient of the imaginary unit, b, and then you also square that, and then, of course, square roots. That number, and it will be a number, it will not have any i's in it at all. It will be a straight up number because it's a distance, and the distance is a straight up number. Why am I stressing that? You'd be surprised of the amount of things I get on Math Excel. Okay, aside from, I don't know, or I don't care, or something that's like completely off base, like radical 2 or something. Sometimes I get the occasional FU, in Math Excel, like screw this. I hope you don't do that. It'll mark you wrong. So, FYI. But I'm telling you because it should look like a straight up number. They should all be numbers here. So it can be a radical. It technically can, but more than likely it's just going to be a number. So let's go through it, and then we'll be done for the day. So I didn't skip it. Boom. Okay, let's go through it. So what's my A value? Well, my A value here is my real value, which is 3, and my B value right here is 4. So I'm going to follow this formula here. That's all. So this equals radical a squared, so 3 squared, and then plus 4 squared. This is going to be 9, and then plus 16, which is radical 25, which is 5. So that is my final answer. That is what I call the absolute value of complex numbers, of this complex number, is 5. Okay, so let's go to this one. We're going to take -1 squared, so -1 squared in parentheses, and then plus, because that's my formula, and then -2 squared, okay? So -1 squared is just 1, and then -2 squared is just 4. So this is actually radical 5, okay? Now notice, this is a radical, right? You can have radicals. It's possible to have a radical. Now also notice that if we had a radical that needed to be simplified, we must simplify it. Okay, this is a really easy one. We don't need to simplify this, so we're solid. But if it was a radical that needed to be simplified, we need to simplify it, or else it's going to be the wrong answer. Okay, let's do this. See? Okay, well, this is going to be plus 0i, right? So this is actually radical, and then -3 squared, and then plus 0 squared, which is not bad. So this is just 9, which of course is just 3. Because 0 squared is 0, -3 squared is 9. Radical 9 is 3. And then lastly, we're going to do this one. This is still also plus 0, so it's not going to affect us too much because -4 squared and then plus 0 squared, that's just the same thing as 16 squared, and then, of course, 4. Boom. That's it. That's all you do it. Like, you'll have probably 1, maybe 2 questions on the homework quiz concerning those questions, so if you need help, if you don't understand, just let me know. But I'm going to erase. Let's go to our summary. What did we learn? We learned kind of multiple different things, similar to imaginary numbers, but we learned how to add and subtract complex numbers, multiply complex numbers, divide complex numbers using the complex conjugate, and we also learned how to plot complex numbers and the complex plane, and then also find the absolute value of the complex number. So we did a lot. I hope that makes sense. Remember, you have retakes that are due this Friday for the Unit 1 test. Okay, if you have any late work or missing work, email me as soon as possible so you can get that in. A lot of Desmos activities or focus note checks are late. Homework quiz tomorrow, complex numbers on Math Excel for today. This is C Squared Mathematics. I'm Mr. Carlson. Peace.